Once again, good morning. So today we will discuss or continue discussing the topic of the quantitative analysis. Last time we have already discussed or emphasized what are the main concern of pharmaceutical analysis. What are the skills that needs to be developed in order to assess the safety, the efficacy, stability, and purity of the substance. Now, we always mention that we will utilize the quantity of the substance in order to identify the four: safety, efficacy, stability, and purity of the substance. But before we can able to assess those four, we need to learn first the principles of pharmaceutical analysis. And that is somehow the biggest challenge. How are we going to translate our skills develop, our knowledge gain, transcribe that into real practice? So now, we will discuss the dimensions of quantitative analysis. First is we have volumetric methods. When we say volumetric methods, we will utilize the liquid state of the substance to identify the quantity. And there are two methods, but we will be focusing on number one, which is the chemical indicator methods. Now, I've mentioned that we will utilize the liquid state of the substance to identify quantity. And there are four methods or principles to identify the quantity. First is neutralization. When we say neutralization, it is a reaction between of an acid plus base, and this is a common board exam question. What will be the product of acid and base reaction? It is salt and water. Okay? Salt and water. Now, next is the redox. When we say redox, it is another method also to identify the quantity of the substance in liquid state with a different principle. In other words, sa ibang process. The process of redox is that it involves the transfer or gain of electrons in order to identify quantity. When we say reduction, it is simply means gain of electrons. And what is the charge of electrons? It is negative, no? And when we say oxidation, it simply means there is a loss of electrons. And oxidation is also known as reducing, aka reducing agent. And reduction is also known as oxidizing agent. Please take note of that, no? Because some of the students will get confused. They thought that the reduction is also the reducing agent. Opposite sila. When we say reduction, that is the oxidizing agent. It is the agent responsible for the gain of electrons or the loss of electrons to the other substance. When we say reducing agent, it is also the substance that is responsible for the other substance to gain an electrons. Okay? And then we have precipitation. When we say precipitation, there is a form of aggregates. There is a form of solid substance. There is a form of crystals. And we will utilize that in order to identify the amount or quantity of the substance and in what state through its liquid state. And lastly is the complexation. When we say complexation, it involves of the substance named EDTA. EDTA means ethylene, ethylene, diamine, tetraacetic acid. Now, please double check the spelling sa inyong own. EDTA is commonly used as an antidote. The mechanism of action or how EDTA works is through entrapment. Trap niya. Now, it is commonly used as antidote for metal poisoning. The mechanism of action for you to easily visualize is that it only traps the metal at the center. And if we try to examine the characteristic or physical features of an EDTA, is that is somehow like this. The inner portion of the EDTA is non-polar. The outside portion of the EDTA is polar in terms of physical appearance or characteristic. Now, the EDTA is used as an antidote because it has dual characteristics. Non-polar yung nasa gitnang portion, polar yung nasa labas. What will be the advantage of that? The EDTA can attract non-polar substance. And when we say non-polar, non-excretable yan through in our urine. Because our urine is composed majority of water. And what is water? Polar substance. The principle will be like dissolves like. Kung magkapareha kayo ng characteristics, you are compatible. Parang ganon. So most of the metals are non-polar. Now, what is the mechanism of action of this as an antidote? It simply traps the metal which is a non-polar, parang sasama siya sa gitna, and then it can excreted in our body, considering that the outside portion of the EDTA is polar and our urine is polar. So, sasama siya going out in our body. So, yung mechanism of action niya, itrap niya sa gitna yung mga non-polar substance, and then because of its dual characteristic, non-polar yung gitna, polar yung sa labas, it can be used as an antidote. Because even though non-polar yung sa gitna, yung outside portion ng EDTA is polar and water is polar, so sasama siya doon sa urine natin in excretion. And that is a way of removing toxic substance in our body. Okay? So that is also part of method of identifying the quantity of the substance. In what method? Diba? We mentioned antidote, but now it's through entrapment. Na-trap na yung substance na gusto nating i-identify yung quantity. And you will much more appreciate this if we can have or you can able to attend a face-to-face laboratory. You will much more appreciate the principles, no, in terms of identifying the quantity of the substance, which will be later on. I'm going to introduce certain formulas. Okay? So I hope this is clear. No? To summarize this one, there are four ways to identify the quantity of the substance. No? So parang ganito yan. Bracket ko para clear. And then dito is the quantity. Shortcut ko na lang. Yan. These four, A, B, C, D, neutralization, redox, precipitation, complexation, are all methods used to identify the quantity of the substance. And we emphasize that it is in a liquid state. I hope that is clear. Now, we will discuss these electrometric methods if we have um, time. No? But the main focus is the chemical indicator methods. And then, next is the gravimetric method. When we say gravimetric method, simply we will utilize the solid state of the substance, its powder state, its granule state, and it involves ignition, or there will be an application of heat. There will be an evaporation to dryness to make sure that there is no moisture content in the substance. Why? Because moisture is a medium for bacterial or microorganism growth. In other words, pag may moist pa dyan, possible yan na makadevelop ng any microorganism. So what will happen? Our product will not conform purity, and most especially the safety, stability, and effectivity of the substance. Okay, so I hope that is clear. And it involves two. We have the chemical precipitation method and we have the electrolytic deposition method. And if we have time, we will discuss colorimetric method and other physicochemical method and gas volumetric method. Okay? Now, let us proceed. No? What is an indicator? No? An indicator plays an important role in the titration process. Now, let me just illustrate to you ano yung normal setup ng illustration. No? This one. And then my holder dyan. This is the stand. So, let me just label. No? This is our titrant. No? Titrant. And this is our analyte. Analyte. And ano nga yung emphasize natin or the main goal of pharmaceutical analysis? Let me just write it here. To, to determine the quantity of the substance. Substance. That is our main goal in conducting this titration. And sino yung i-identify natin? Identify natin si analyte. Okay, lagay ko dito, analyte. No? Analyte. The substance that we're trying to identify is present in our analyte. Dito. And analyte is added with an indicator. No? So this is plus indicator. Yan. Okay? So always remember that this is the um, setup of titration process. And our always objective is to identify the quantity of the substance. And saan natin malulocate yung unknown substance? It is in the analyte. Just let me write the legend, no? Or the definition. When we say titrant, known concentration. And when we say analyte, unknown concentration. Concentration. So yan. I hope this is clear. So yan. No? Titrant, known yung concentration. Analyte, unknown yung concentration. And sabi ko kanina, indicator plays an important role in the titration process. And let us define what is an indicator. Indicator is simply a chemical which change color at or very near the point in the titration where analyte where equivalent amount of analyte and titrant have reacted. And it is 1:1 ratio. Anong ibig sabihin ng 1:1 ratio? Sir, let me just input here. 1:1 ratio means 1:1 ratio means one molecule of the titrant would react one molecule of the analyte. Yan. One molecule of the titrant and one molecule of the analyte would react. Hindi pwedeng 2 is to 1, 1 is to 2, vice versa, 3 is to 5. It should be 1 is to 1. Now, the biggest question then would come up in your mind is that how can we count the the number of molecules in order to achieve the 1 is to 1 ratio? That is the biggest question that we will answer. Paano natin i-count yung molecules na hindi man natin yan nakikita? We can see that macroscopically, powder state, liquid state, but looking at its chemical position, geometrical position in terms of molecules, atom, our eyes is not feasible on doing that. That is why I've always mentioned to you na we will use its other identity, its molecular weight. We will use this as an identity of the atom or the element for them to be identified. Now you observe there is no single element in our periodic table which has the same molecular weight. And if is, kung naa manggaling, it's not for us difficult to identify because I don't believe na most of it. Pero, theoretically, there's none. So, what does it mean? We can identify individual element based on their molecular weight. And you need to memorize that. You cannot answer the exams. You cannot perform the titrations. You cannot understand fully the definition or behind the principles if hindi nyo ma-memorize yung molecular weight. And aside from that, memorize also the chemical formula. Common name, chemical name, which is posted in your Google Classroom. Okay? So, equivalent amount of analyte and titrant have reacted. What does it mean again? One molecules coming from your titrant, for example, NaOH, and one molecule of your analyte, no? For example, HCl. So in other words, unknown yung quantity ng HCl natin. Hindi natin alam kung ano yung concentration niya, yung amount niya. 'Di ba? I differentiate concentration and solution. When we say solution, it is the physical characteristic of the substance. Simply, solute plus solvent is equals to solution. But when we say concentration, it involves amount or quantity. Amount of your solute that is mixed to your solvent which has a specific amount also. And that is concentration. I hope you see the difference. Okay? Concentration, it involves amount or quantity. Emphasize yung amount ng solvent mixed together with an specific amount of solvent. And when we say solution, simply means it is a term used to describe the mixture of solute and solvent. But when we say concentration, quantity of the solvent or quantity of the solute mixed to a specific amount of solvent. And that is concentration. So be careful of using properly the terms. No? So the biggest question, how can we count the number of molecules? And later on, there are formulas or methods to perform on how to count the number of molecules. Okay? And indicator will change color if na-detect niya na equal na yung amount coming from your titrant already reacted. Mag-change yan ng color. And that is also a determining point that the titration must or at the end point already. Meaning needs to stop because equal na yung amount na nag-react coming from the titrant and analyte. Now, let's go back to the first question to identify the quantity. Sabi mo, sir, 1:1 ratio. Our main objective is to identify the quantity. How can we use the 1:1 ratio to identify the quantity of the analyte? Through its reaction. Sabi natin, define natin kanina, known concentration. Ibig sabihin, alam natin kung ilan or how many yung substance. Let us presume, assuming natin ha, there are 20 molecules of this. And then sabi natin 1:1 ratio ha, 1:1 ratio. So upon titration of substance, let's say this is 20 MEQ or number of molecules. And then upon titration, nag-change yung color after we consume 10 MEQ. So anong ibig sabihin? If we apply the 1:1 ratio, 1 molecules of the titrant, 1 molecules of the analyte strictly followed, ilan yung quantity ng analyte natin? So, using the 1:1 ratio, the quantity of our analyte is also 10. No? So, I hope you were able to get the principle on how to use the titration process in order to identify the quantity of the substance. Now, this is not somehow one-shot deal. Hindi yan na in the first look you can already get. It needs to be uh, uh, further reading, no? Further practice, no? Review of the notes. Okay? And then let's proceed to its unit, di ba? This whole titration process have identity, no? Just like the other units, no? Uh, it's not um, applicable to say that after titration process, di ba, we have a result or quantity because that is our main objective to identify the quantity of the substance. And when we say quantity, it should be something or something numeric, number form. Now, we cannot say that it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, the readers or the interpreters will get confused. What does it mean? 10 orange apples, 10 papers, 10 persons. We need to give an identity to that titration process. And this titration process, no, is identified as normality. We use normality as a unit. Okay? So when we say normality, it is an expression of concentration. Now, I've mentioned earlier, ano yung definition ng concentration? It is the amount of your solute mix together in your solvent to give a specific quantity. Now, state there expression of concentration, meaning normality is used to indicate a quantity of a certain molecules with that specific volume. And it is emphasized that it is in terms of gram equivalent per liter of solution. To to fully understand, no, or get what does the definition trying uh to relay is that it simply says how many molecules is present per liter. Yan yung ibig sabihin ng normality. If we will draw that, no, the units is subject to change, no? But yung important to consider there is that in every proportion, in every portion of liquid, it's either 1 ml, 2 ml, 3 ml, 5 ml until 1,000 ml, alam nyo yung portion ng molecules present on that volume. And that is normality. In every volume, a specific volume, how many molecules are present. No? So that is normality. And then these are the units. N or equivalent per liter or MEQ per liter. No? So you observe there is a per liter. And then the MEQ there is sort of parang unit ng how many molecules are present. No, parang isang molecule that is identified as 1 MEQ. Two molecules that is identified as 2 MEQ. Three molecules that is identified as 4 MEQ, 4 molecules that is identified as 4 MEQ. No? So, yun. Now, let us proceed to the formula. There are three sets of formula. The first set of formula is contain two formula. Equivalent weight is equals to molecular weight divided by valence. Now there is an if, no? If valence is acid based on the quantity of hydrogen ions. If based on the quantity of OH minus or ions. And if it is salt, based on the subscript, no, of the cation. And then if if no subscript subscript based on the charge of the cation, no. And then second set of formula is the milli equivalent weight is equivalent to equivalent weight divided by 1,000. Now, that is the first set of formula. This is the second set of formula, no? So, yan. The second set of formula, second set, is that involves number of equivalence. Equivalence, number of equivalence is equals to weight, uh, weight, or weight of the substance divided by equivalent weight. The number of milli equivalence is equals to weight of the substance divided by milli equivalent weight. Now be careful because usually ma-interchange ni siya sa students ang formula because of the words na medyo similar, no? So yan, take note. That is the first two set of formula. Now take note. Step 1 of formula is always perform. Huh? Meaning, you cannot proceed to set 2 if you will not perform set 1. Okay? And unsay pinaka-vital na variables sa first set of formula? Molecular weight. Anong ibig sabihin? If you cannot memorize the molecular weight, meaning you cannot go further on the calculations. And what will happen? You don't have answer. So please memorize molecular weights and the different chemical formula. And I mentioned first set of formula is always calculated. Sulat nato para dili jud malimtan. Ang first set of formula always calculated. Lock. And then the second set of formula depends if it is asked by your instructor. But let me emphasize to you. Unsay akong giingon ganina? Unsaon pag count sa number of molecules. And unsaon siya? Through the use of these two formulas. These two formulas are used to identify how many molecules are present. Kung sa Bisaya pa, ang pasabot sa number of milli-equivalents or in Tagalog is that ilan yung molecules present at that specific volume or weight. In Bisaya, ang murag translation silbi ba of number of milli-equivalents or number of equivalent is that. Kung i-translate nato sa Bisaya ang number of milli-equivalents, pila ka molecules is present anang particular nga timbang. For example, sugoon ta mo 10 grams of baking soda. No? So sa 10 grams of baking soda, you will count how many molecules of baking soda is present sa 10 grams. For example, 10 ml of HCl, pila ka molecules of HCl or hydrochloric acid at 10 ml. And we can able to do that through the use of this formula, no? So ang set 2 of formula is not always calculated. Ano to? Not always calculated, but however, uh, not always calculated, but depends if is as ana, or gi-emphasize na ako sa kong instruction sa exam nga calculate the number of meal equivalents, calculate the number of equivalents. Okay? So it is not always calculated, but depends if it is asked. Okay? So yan yung two sets of formula. And then always remember, you cannot proceed to the second set without performing the first set, because there is a portion in the second set of formula na it needs the answer coming from the set 1. Observe the formula. Weight of the substance divided by equivalent weight. And then how are you going to calculate the equivalent weight? Using this formula. There is also a portion that you need to find first the meal equivalent weight. And how are you going to calculate the meal equivalent weight? Using this formula. And using this formula, you cannot attain this answer or this formula without doing this formula. And unsay pinaka-vital diha? Molecular weight. So kung walay molecular weight, wala ka ani, wala ka ani, wala ka ani. Gets? And then, lastly are the general formula. Now, according Einstein, no, si Albert Einstein, all of his formula or or output is translated into formula, di ba? The latest formula of or uh, the controversial formula of Einstein is that E is equals to mc squared. No, I don't know if correct ba akong pagka pronounce. No, it's the same also in pharmaceutical analysis. No, the titration process, di ba, nag-perform tag titration, and then we have the analyte. No? So this is the holder, and then this is analyte plus indicator, and then this is the titrant. Now, this whole titration process is interpreted or transcribed or translated into formula. Now, the purpose of this, gi-introduce na ko or gi-emphasize na ko ni is that during the performing of the titration process, you can able to identify the variables. No? So, ang pinaka-general formula is kani. Normality is equals to the weight of the substance divided by volume times milli equivalent weight. 'Di ba nag-ingon ko ganina, the whole titration process is identified as normality, which is correct. N is equals to. Now the weight, asa man na makitaan ang weight, sir? Weight is located or can be found on the analyte, no? Kaning weight diri makita sa analyte. This is the weight of the substance that you measure, 'di ba? Sa mga nag face to face, this is the weight of the substance that you measure, 'di ba? And then the volume is coming from the titrant. Now, this is the volume where it stop because nag-change na og color ang indicator. So, kung asa siya nag-stop, that is the volume. And then the milli-equivalent weight, that is the milli-equivalent weight of the uh, analyte or the specific substance identified. No? The milli-equivalent weight. So, duha man ni ka substance involved, NaOH, and then HCl. No? So, ma-confuse pa ka kinsa man nga milli-equivalent weight ang among i-calculate, sir. No? Di ba? Gi-present man ni sa formula ganina sa first set kung saan ni pag-calculate. Now, ma-confuse pa mo. Kinsa man nga milli-equivalent weights, NaOH or si HCl. Always remember, it should be the milli-equivalent weight of the analyte. So, importante nga makabalo mo kinsa si analyte, kinsa si titrant. If you ma-interchange ninyo na, you will get a wrong answer. No? Okay? And then the NAVA and NBVB, this is simply involves two titration process, no? So ang pag-rearrange ani is something or really something, no? Same gyud siya sa extreme and mean sa ato ang PharmCal, no? NBBB, no? So ako lang i-verbalize ha kay humanaman sad ninyo nagyan sa PharmCal, no? So kung missing si Na, the formula is NB times VA divided by BB. No? So kung missing si NB, the formula is NA is equals to NB is equals to NA times VB divided by BA. So same with other variables. No? Unsaon siya sa pag-cross multiply. No? And then these are the another set of formula. No? Include this. Include this. Sa katong mga na-discussan nako, include this in your formula. Please include this in your formula. And then also i-clarify ko lang i-clarify ko lang sa mga na-discussan nako sa portion sa formula uh, based on the quantity of OH ions, no? So please remove the ID carbonate, no? Error tong carbonate, only OH ions. Okay, sa katong mga na-discussan ako, remove the carbonate. Okay? Remove the carbonate, no? Remove the carbonate. Okay? And then include this formula and then this formula also. Okay? So that are or those are the coverage of the exam, no? So those are the coverage of the exam, and there is a practice problem for you to answer, no? So I will post this in your Google Classroom. Answer this if you have time. Just make sure na dili maabot na next week. Deadline of this will be Sunday, all sections. No? Kung naamoy bakante, this is very simple raman na ana po yung formula provided. And then may I ask those students nga kanaang naka-participate gyud sa face-to-face, please help your classmates na sa online. This is not a competition, this is a teamwork, no? You help them, no? Let us move together. No one will be left behind. That should be our objective, no? So tinabanga tatabangi sila, kung mangutana sila ayaw ninyong i-disregard. Kung na sila clarification, please um, help them, no? In behalf of me na lang. Tabangi sila, okay? So that would be all parts coverage midterm. Further announcements will be posted in your Google Classroom. Thank you very much and God bless you all.